Welcome back, viewers, with the third lecture of this online series of lectures on the course of Introduction to Category Theory. We presented the basic concept of an Olog by means of an example in the first segment, and in the second segment we were presenting the key features associated with an Olog. We started out with the types, and we have seen that a type is an abstract concept, a distinction the author, the creator of the Olog, has made. Okay. So we represent, as we have seen in our previous example, that we had multiple boxes, and those boxes were precisely the types of the Olog. So we represent each type as a box containing a singular indefinite noun, indefinite noun phrase. Okay? It is important. It's one of the rules of this game that you label the boxes by a singular, a singular indefinite noun phrase. So examples, I'm giving you some examples here by drawing some boxes. Each of the following four boxes is a type. Okay. A man. A box labeled by a man. An automobile. Another example of a type is a pair A, W, where W is a woman and A is an automobile and A is an automobile. Okay? So we cannot put a punctuation sign here. That's another rule. We'll write down the rules later. Rules of good practice later. We had another example of a type here. A pair, singular type, a pair A, W, but of course different, where W is a woman again, where W is a woman, and A is a blue automobile, and R and A is a blue automobile owned by W. Observe that there are more restrictions or constraints put in this type than this one, than the one on the left. Alright? Okay, again I missed it. I put a punctuation sign here, I should not. Okay. So these are 4 examples of types. So each of these four boxes represents a type of thing, a whole class of things, a whole class of things. Thus, okay, there is another thing. So these are the types that we have in the Olog, in the diagram of an Olog. But whenever we try to put them in the text, we do not put them in boxes. We put them in corner symbols, like I'm doing now, plus a map. This is the corner symbol. This is just to avoid the typographical errors. For that reason, for titles, so that we don't have any titles while we are discussing the Olog facts. In order to avoid the titles, we will put these texts of the types inside the text, inside the sentences with these common symbols. Okay? So a man, it means the type that we are discussing, this type, but instead of putting this a man inside a box, we are putting them inside these corner symbols because now we are discussing them inside the sentence. Thus the man does not refer to a single man. But it represents, I have highlighted this in my notes, represents, it's important to understand what it means by represents here. It represents the set of men. The set of men. Each example of which is called a man. Okay? So this box, which is a particular type, represents the set of men. It does not mean that this box itself is the set of men. This is the subtle thing happening here. It is not the set of men, but it represents the set of men. Okay? So it is an abstract concept of a man, which represents the set of men, and each example of this set is called a man. So these are two distinct notions. This is the type, and the set of men is another notion, which is a set. This is the type that we have in the Olog. This thing written inside the box is the type that we have in the Olog, and the set of men that it represents is a set. These are two distinct notions, alright? But related to each other. But how they relate? By means of a concept that we will discuss later. Okay. Alright. Let me erase this box. So I have highlighted this particular sentence that I am writing now in red color in the lecture note for for a valid reason. In other words, types in Ologs are intentional, rather than extension, extensional, and the extension of this type of a type, is captured by the instance data, like we had for this example. So the set of men here is the extension of this type of a man. Okay? Rather than extensional, the label on a type describes its intention, So this label actually this label attached to this box describes its intention only, okay? The extension of this type is captured by the instance data, which is precisely the set of men. The extension of a type is captured, rightly captured by instance data, which in this case is the set of men. Correct? This is what we have written down in the lecture notes. Alright? Okay, so here, look at this box or a type which probably has a million examples, right? There can be million of examples of this pair, a pair of A and W, where W is a woman and A is a blue automobile owned by this woman that we have put down here. There may be millions of examples, or in other words, we can have millions of pairs satisfying this criteria. Okay. But for all those million examples, there is a common theme between all those examples, which is captured by this text written down here. This label that we have for this type, this captures the common theme between all those examples, all those million examples. Okay. Now I want to clearly state something related to this notion of type so that we are not confused with the notion of types being the same as the notion of set. Alright? So I want to write it very clearly that I want to clearly state that it's stated at this point that at this point that automobile. An automobile. So I'm writing this back with reference to this example of type that we have written down here, an automobile. An automobile is not the set of all automobiles. So an automobile, the type is not the set of all automobiles. Rather, it is an abstract type. I want to underline this abstract word also. Abstract type, which represents, like I told before, which represents the set of all automobiles. All automobiles. Being different from the set of automobiles. Okay? It just represents this set, but not being the same. Here in this example, see that the set of all automobiles, the set of all automobiles, the set of all automobiles is the extension of the type and automobile. It includes in these common symbols. So you need to really think about it very closely, because there is a subtle distinction between this type and the set that this type represents. So there may be types with compound structures that we need to understand. I'll give you a few examples of types with compound structures. We already had two of them here, with this pair and another pair that we had on the left. And there are good rules of denoting these compound structures. Okay. Okay. So now types with compound structures. With compound structures. Many types are composed with smaller units. Examples include a man and a woman. This is the type consisting of smaller units, a man and a woman. Another very good example of a type is a triple. A triple, P, A, J, where P is a pair, A is an author of P, A is an author of P, and J is a journal, and J is a journal. where P was published. P was published. Okay? So it is a good practice to declare the variables associated with smaller units in a compound structure, meaning that we should denote the smaller units of a man and a woman with symbols, say with A and W. So it's preferable to replace the first box. It's preferable to replace it with this box. A man, M, and a woman, W, for this type. It can also be that the same idea can be captured with another type, which is similar to the type that we have written down here, or with this, or up here, M, W, where M is a man and W is a woman. Okay, so now we need to learn the rules of good practice that I'll write down in the last segment of today's lecture. So let me get back to you on the third segment of today's lecture and give you the rules of good practice. Thank you very much.